In this lesson, we will learn how to work with standard normal values, which really means knowing area under the curve can we find the corresponding z-score meeting certain conditions. Let's take a look at our first example. Let z be a standard normal random variable. Use the calculator provided or the table to determine the value of c such that probability of z being less than or equal to specific value of c is 0.8790. So I illustrated this on a picture in front of you. I'm saying we have a normal curve centered at mu equals 0. I would like to know what is this boundary point, what is this z-score, so that area to the left of this unknown z-score happens to be 0.8790. Well, two things to be aware of. We are now working with inverse function. We're not looking for area. We are looking for z-score corresponding to the area. And in this case, there is certain notation used for it. We use a subscript to indicate how much area there is to the right of that z-score. So to be more specific, if this area, the highlighted one that I am given, is 0.8790, then the remaining area must be 1 minus the given area, or 0.121. So that is something I can find myself by subtracting given area from 1. Okay, so that much we know. Your textbook, and it's very typical, is indicating this location, the z-score, as z sub 0.121. This subscript, in general called alpha, z sub alpha, is such that alpha is the area that is always to the right of that z-score. For example, if I have z sub 0.85, it means visually that there is a location z, some z-score, so that there is 85% of area under the curve to the right of z. Therefore, we can conclude there will be 15% left on the left side. Let's see how we can answer this question using the calculator provided by ALEKS. So here I'm going to open ALEKS calculator, and the function I'm going to use has form z subscript, where I can enter any area under the curve in that subscript. So if I enter the area provided to me, look at what the result is going to be. The result happens to be a negative number. Why? Because if I entered the information provided to me in the problem, where area is 0.8790, what I did, I found a z-score that is to the left of 0, so that there is 0.879 or 87.9% of data to the right of it. Because remember, this notation, z sub alpha, is always the amount of area to the right of the z-score. And that's not exactly what I'm looking for. I am looking for the z-score so that the area to the left is 0.879, or as a result, area to the right must be a 0.121. So it will be better if I enter this number into this function on the calculator. Let's see how that works. So I continue. I notice that it's strange to get a z-score that is negative with the originally given question right here, right? It doesn't seem like it's going to be a negative quantity. So I'm going to try again and use the same function of 0.121 now instead of the area given to me exactly in the problem. As you can see now, the answer is the correct answer. The answer is 1.17 is my C value. In other words, by the way, I definitely have to check for the rounding requirements, and it says to round to 2 decimal places, and the answer is correct. So what I'm trying to show here is, in reality, You could find this answer using either of those areas. You could use area of 0.8790 or area of 0.121. It doesn't matter which one you use. You just need to interpret it correctly. If you use this first approach and you found negative 1.17, you just need to realize that these two are symmetric about 0. All you need to do is lose the negative and write your answer in the window right here as 1.17 because you found a mirror image of the z-score you're looking for. Or you could think of it, well, right before you enter things into a calculator and just use area of 0.1 to 1 so that you're consistently using the right notation with z sub alpha, where this is the right alpha or right amount of the area to the right of the z-score you are searching for. Whichever way you do this, you can always arrive at the right conclusion. And in this case, z-score is 1.17. Now let's do the same problem using TI-84. Depending on which version of TI-84 you have, you may have slightly different directions or way to enter the information. So for older versions of TI-84, you are going to use inverse norm function, but this function only takes into consideration area to the left of z-score. So if you want to find z-score corresponding to a certain area, it is always area to the left. On the newer calculator like this version, TI-84 plus CE, you can choose where your area is, to the left, to the right, or in the center. So let's see how it's done for this particular example. We go to second vars, which is going to take us to distribution menu. Choose inverse norm as our function. Enter area that you have. In this case, area to the left is 0.8790. Mu and sigma are standard for normal curve. And here, as you can see, we get to choose left, center, right. On older versions, you don't get to choose. Press enter a couple of times and you got your answer is 1.17. On the older versions of TI-84, you will not have this line at all available. You will not get to choose left, center, right. It will always be assumed that area is to the left automatically. So that's my comment right here. For some calculators that are a bit older, area is always to the left. If you're using this version plus CE, you get to choose whether your area is to the left, to the right, or maybe you work between two z-scores and you're looking for the area in the center. Here is one more example for us. Let z be a standard normal random variable. Use the calculator provided or this table to determine the value of c such that probability of z being greater than c is equal to 0.1867. Around your answer to 2 decimal places. First of all, I would like to get a diagram of what's going on here. I have a normal curve and I'm looking for a location where there will be a z-score value of c so that to the right of it there is an area of 0.1867. If there is this much area to the right, then 1 minus that amount will give me 0.8133, which is area to the left of this same number I'm looking for. Using the z sub alpha notation, z sub 0.1867 is exactly what I'm looking for, and as I'm entering this into ALEKS calculator, I get 0.89 rounded to 2 decimal places. Using TI calculator, I can do this in more than one way, so I want to demonstrate all 3 possible ways, 3 obvious possible ways. How about that? So first one is to enter inverse norm and say we're looking for the area of 0.1867 with standard mean of 0 and standard deviation of 1 for any standard normal curve. And I will indicate on my newer calculator that that area is to the right of this unknown z-score I'm looking for. When I enter this, I'll get 0.89, just like I did using ALEKS calculator. Another option is to still use the same value, but indicate area to the left. What really it means, let me make a change. What it means is I'm looking for a symmetric C value so that there is this much area, 0.1867 to the left of it. And I just make sure to take a negative of that value because the value I'm going to get will be negative and I don't want it to be negative. So by taking an opposite of this quantity right here, I am taking the opposite of this negative z-score I'm going to get, which is going to give me a mirror image of it and will give me the C I'm looking for. Lastly, one more way to do this is to say, let's find inverse norm of some z-score whose area to the left is 0.8133. In other words, this time I'm looking for the same C value so that area to the left of it is the remaining 0.8133. And that will give me 0.89 as a result as well. So as you can see, there are so many ways to look at the same location C, depending on which number you want to use, which tail you want to use, left, right, and so on. So find the way that works for you. Use common sense. Definitely use images and diagrams to give you a better understanding what you're looking for and what it should be. Should it be positive outcome or negative outcome for Z? Here is the final example in this video. Let Z be a standard normal random variable. Use the calculator provided or this table to determine the value of C such that probability of negative C being less than or equal to Z, which is less than or equal to positive C, and that is equal to 0.9385. So what this means is I'm looking for two Z values which are opposites of each other. So obviously there is a symmetry involved. And the symmetry here would be about the mean of 0. So I'm looking for these two locations, negative C and C. In reality, it's enough for me to find one value of C and just, to find this one, I'm just going to take an opposite of that. So that area between them, that's what this inequality means. So any z-scores between these two values of negative C and C will produce area that is a 0.9385 altogether combined. Well, if the central area is a 0.9385, the two tails will contain the remaining area, which we get by subtracting the given area from 1. Because there are two tails, the remaining area will be divided evenly between two tails. So here I go. To find this alpha, I need to find 1 minus 0.9385, which is 0.0615, divided by 2. And it means in each little tail right here, I have a 0.03075 amount of area here and here. Symmetric, same quantity. Because I want to find C value that satisfies this condition, it is enough to find the z-score with alpha of this amount, the area to the right of the z-score. Well, using ALEKS calculator, it's really easy. Z sub 0.03075 is 1.87 when rounded to 2 decimal places. To find the same result using TI-84, we can do it in more than one way. So let's take a look. Z sub 0.03075 can be found by inverse norm applied to the area of 0.03075 with mean of 0 and 1 as standard deviation. And we're going to indicate that this is the amount of area to the right of that unknown z-score, and that gives me 1.87. Another way to say is find the same inverse norm of same area, but use a left tail, which really means I'm going to find the z-score so that there is this much area to the left of it. All I need to do is take opposite of the z-score to land with a positive C. So I take opposite of this result and it gives me back 1.87. This is probably what you would do if you use an older calculator, because older calculators don't give you a choice of left, right, or center. It always calculates area when it's to the left of your z-score. So you would have to use this approach. Lastly, with a newer calculator, you could literally say, okay, there is this much area of 0.9385, here it is, in the center, and it will give you the same result. In fact, I would like to show one more way of finding the same result that may be especially useful for students who are using older TI calculators. In this case, we're going to find z-score using the area to the left of this unknown value c, and we're going to take everything to the left of this value. Therefore, I am combining the center area of 0.9385 with the left tail of 0.03075. Together, they give me this quantity of 0.96925. Let's apply inverse norm to this area with mu 0 and sigma of 1. And your older calculator doesn't give you a choice of left, right, or center. It just always computes area to the left, which is what this area is, area to the left of this unknown value c. When I apply this inverse norm to this area, I also can get 1.87. So again, it is just another way to find the same quantity. Now we're going to go back to one of the examples we already worked with, but I would like to demonstrate to you how to use a table to answer questions of this type. So we want to find the probability that a z-value is less than or equal to c, and c is what we don't know and try to find, and the area to the left of c must be equal to 0.8790. So I'm going to visualize what's going on here. I am going to put a mean of 0 in the center. I know that majority of area has to be to the left, about 88% or so. So I'm going to guess C must be somewhere here, and it separates majority of the data from the tail on the right side, and this area should be 0.8790. The question is, what is this value of C that separates 0.8790 from the rest of the area under the curve? We are going to check the tables that are included with your textbook. The standard normal distribution table has more than one page, and we will need to find the right page for this particular example. Remember, I'm looking for z-value that will separate 0.8790 or 87.9% of the data from the remaining percent of the data on the right side. And if I look inside of this table and look at the interpretation of this table, here's what it says. It says that the information within this table tells you how much area there is to the left of a certain z-score, where z-score can be identified by looking at the first column together with the first row. Please notice that the first column contains the ones and tenth place of the z-value, and the row indicates the hundredth place of the z-value. For example, negative 2.7 together with this 7 means negative 2.77, or z-score of negative 2.77 has area to the left of it equal to 28 10,000ths. If I need to work with a positive z-value, which is the case in our situation, right? We have a positive z-value because it is on the right side of 0 based on our diagram. I will need to move on to the next page and find the information there, because the next page has information about positive z-scores. So here I am looking at the next page where the z-scores are all positive, and I'm expecting something like that to happen with my particular example. My task is to find the value inside of this table that is as close as possible to the area I am considering. In my case, it is 0.8790. So I'm looking for, okay, 60s, 70s. Okay, here are my 86, and here becomes 87, and I'm looking until I reach here. Here is the number I was looking for. Actually, it's a perfect value, not even approximate, a perfect value as I wanted it to be. So I found the area under the curve to the left of z. And what is my z value that does this? It is 1.17. So z value of 1.17 has the area to the left of that value that is equal to 0.8790.